welcome to all. Myself Dipti Patnaik. I am assistant professor in Department of Electronics and Communication Engineering at GL Bajaj Institute of Technology and Management, Greater Noida. So, this is the fourth consecutive lecture on the digital modulation technique. So, previously we have studied about the Bpsk, Bpsk and Bpsk, that is binary amplitude shift keying, binary phase frequency shift keying and binary phase shift keying. So, on that analysis we have seen about the probability of error and the signal constellation diagrams. Now, we will see one new type of Psk, that is your differential Psk, and how it works we will see in this lecture. So, the Dpsk is nothing but your differential phase shift keying. In the previous we have seen that there is only normal phase shift keying. Okay. So, see what will happen here. Differential phase shift keying, that is Dpsk, is a type of phase modulation. Okay, that Bpsk was also a phase modulation. Here this is also a phase modulation that conveys data by changing the phase of the carrier wave. So, definition is same for Psk and Dpsk, that is your phase of the carrier wave is changing for conveying the data. Okay, that is nothing but your one type of phase modulation. So, herein the phase of the modulated signal, okay, phase of the modulated signal is shifted relative to the previous signal element. We will see what this point wants to tell. The phase of the modulated signal, modulated means after modulation. Okay, after modulation means after message operation on message and carrier signal. So, that is your modulated signal or transmitted signal. Okay, transmitted signal. So, this signal is shifted relative to the previous signal elements. We will see why it is why it is depending on the previous signal element. So, the signal phase follows the high or low state. So, the signal phase, we are focusing on the phase, that is signal phase, that signal phase follows the high or low state of the previous elements. So, here we can see that it depends on the previous signal, that previous signal's phase. Okay, this is the point. Okay, whether this is a high phase or low phase, we will see. And mainly this is the a non-coherent binary modulation technique, and before this non-coherent means in the receiver section we are not using a carrier signal to detect the transmitted original transmitted message signal. Here we are not using any carrier, but in case of Bpsk we have used the carrier signal to detect the original message signal, that was your coherent Psk. Now, it is non-coherent Psk. This is the main point. Okay. So, the modulation scheme in which the detection process does not need a carrier at the receiver. Okay, to be phase locked with the transmitted carrier is to be non-coherent. I have just told you this is non-coherent is nothing but the detection process does not need a carrier. Okay, detection process does not need a carrier signal. So, Dpsk eliminates the need of coherent reference signal. Okay, that is why it is known as non-coherent binary modulation technique. So, here I have detected these points elaborately. Okay. So, Dpsk eliminates the need of coherent reference signal at the receiver by combining two basic operations at the transmitter. So, here we have seen that we are just omitted the coherence technique. Okay, now what new technique is added here? Here the new technique is your input binary waveform is encoded differentially. First, the input, whatever the input binary signal is there or symbol is there, we have encoded that binary waveforms differentially. Then second, what will happen? Then after differentiation, we were phase shifting that inputs. Okay, we will see what will happen. So overall, it is for symbol 1, the carrier with 0 degree phase shift is transmitted. For symbol 0, what will happen? A carrier with a 180 degree phase shift is transmitted. So for symbol 1, we are transmitting the carrier signal with 0 degree phase shift, and for symbol 0, we are transmitting the carrier signal with 180 degree phase shift. Okay. So you can see this is the Dpsk transmitter. Okay. So here one unit is there, that is your XNOR gate. This is your XNOR gate, and that is and this is your delay unit. Okay, this is your delay unit, that is 1 bit delay unit. This is 1 bit delay, not more than 1. Okay, this is the delay. Only delay means it can be delay 4 units or 5 units, 10 units, whatever, but here we are delaying the units how much? By 1 bit. Okay, so we can see that one XNOR gate is there, that is your our input signal is this Bk's binary input sequence, and this the output of the XNOR gate. This is the output of the XNOR gate is again transmitted to the input with a delay. Okay, so here you can see it consists of a logic network. Okay, this is a logic network and a 1 bit delay element. This is 1 bit delay element interconnected so as to convert the raw binary sequence. This is the raw binary sequence Bk into a differentially encoded sequence, that is your Dk. This is your what? This is Dk. Okay, this is the differentially encoded sequence Dk. So this process starts with an arbitrary bit acts as a reference. Okay, so see, to start this operation, I have to first take the Bk value. Okay, otherwise we don't have this Dk minus 1. Okay, so I have to start with arbitrarily taking one bit as 0 or 1. Okay, so that is known as reference bit, and thereafter the differentially encoded sequence Dk is generated by using the equation. Dk is nothing but your Dk. This is your Dk is nothing but XNOR. XNOR. What is the logic of XNOR? That is your Bk. This is your Bk, and this is your Dk minus 1. Okay, so after delay with 1 unit, this is was Dk, and the input is Dk. Output is after Dk minus 1 represents the 1 bit delay of Dk. Okay, so okay, this is the Dk equal to XNOR operation, that is Bk XNOR Dk minus 1. These are, you can say this is simple. One XNOR gate is there. Here one, this is Bk, this is your Dk minus 1, and your output y is nothing but your, or this is the output Dk. You can say this is nothing but this Dk equal to Bk XNOR Dk minus 1 equal to your Dk minus 1 Bk plus Dk minus 1 Bk, Dk minus 1 bar multiplied by sorry Bk bar. Okay, and this is the your XOR operation, and this is the XNOR operation. XOR operation is it is nothing but the output will be 1 when inputs are different, and if in XNOR case output are 1 if inputs are same. Okay, this is the truth table. So after decay, it will pass through a amplitude level shifter, and where it will generate the binary waves, and again it will transmit through a carrier wave using the carrier wave, and lastly we will get Dpsk signal. Okay. So see, this is the how we will go through this Dpsk. This is your input binary sequence 1 0 0 1 0 0 1 1. Now we will see what we need. This is Bk, Dk, Dk minus 1. Our output should be Dk. XNOR output is Dk, and your input are Bk and Dk minus 1. This is a Bk, Dk minus 1. This is your Dk. Okay. So we have to first we have to first assume that Decay is initially as a 1. We are assuming Decay as a 1. So Bk is your constant. We cannot touch also. Okay. So Dk minus 1, here we are we are assuming 1. 1 means it is again going 1. Okay. So Bk we have 1. So Bk we have 1. Dk is nothing but your Dk minus 1. This is your Dk. Okay. This is your 1. So after 1 1, I am getting this is 1. This is 1. I am getting this is how much we will get. If same inputs are there, then we will get, see, if same inputs are, then we will get 1. Okay. Okay. If same inputs are, see, same inputs 1 1, I will get 1. Again this bit will shifted to acts as Dk minus 1, and it will again treated as a one input, and you have in next interval we have 0. So now what will be the decay? Decay will be the x naught of 0 1. X naught of 0 1 is nothing but your 0. Again this bit will shift to the act as a, now it is 0, now it is decay, but it will act as a, for next bit it will act as a decay minus 1. Again this will be, what will happen, this both will are equal. Again equal means output will be 1. Again it will act as decay minus 1. Again same input, output is 1. Decay minus 1 it will act as decay minus 1. Different input, output is 0. Again it will shift to 0, decay minus 1. Again same input, output is 1. Again same input, output is 1. Again same input, output is 1. So for 1 we are considering the phase shift is your 0 degree. For 0 pi degrees phase shift. For 1 again 0 degree. For 1 0 degree. For 0 pi degree. For 1 0 degree. For 1 we have 0 degree phase shift. Okay. So the differential encoded sequence decay thus generated is used to phase shift a carrier wave with phase shift angle 0 degree and pi degree radians, representing symbol 1 and 0 respectively. Okay, for symbol 1 it is phase shift 0, and for symbol 0 it is phase shift pi degree. Again the same, this is the input binary sequence. Okay, now this is your carrier signal. Now we can see that phase shift to 180 when the input XOR gate are similar. Okay, if next bit 1, polarity will change. Okay, see here bits are 1 1. One bit is your 1. First bit is your 1. So same phase. If next bit is also 1, then what will happen? The differentially encoder what it will do? it will phase shift by 180 degree, that is polarity will change. See this up to this much it is 1, again this is 1, then 1 after 1, so phase shift is changing. Okay, see from 1 to 0 transition is 0, phase shift is not changing, that is 0 degree phase shift, there is a 0 degree phase shift. Again we will say 0 to 1 transition, see 3, that is phase shift is there. Okay, again 1 to 1, again phase shift is change. Again 1 to 0, there is no phase shift change. Okay, 1 to 0 means no phase shift, and 0 to 0 there is no phase shift change, 0 to 0 there is no phase shift change, it will continuously going on. Okay, so if next bit is 1, polarity will be changed. If next bit is 0, there will no change in polarity. Okay, so this is the Bpsk receiver. So we can see that there is no carrier signal at the receiver, what was used in previous cases currently. So your input is Dpsk sorry, input is your Dpsk carriers, Dpsk transmitted signal. It will pass through a band pass filter, and then it will pass through a product modulator, and with that product modulator will product the input signal coming from band pass filter and its delay unit, and then it will pass through a integrator, and this whole product modulator followed by a integrator is nothing but your correlator. Okay, so and after that it will pass through a sample circuit, and that output L will then pass through a decision device, and that decision device will check whether that signal is greater than the threshold or less than the threshold. Accordingly it will decide whether it should be 0, it should be considered as 0 or 1. Okay, so at the receiver input, the received Dpsk signal with noise is passed through the band pass filter. It is coming with noise. Okay, centered at the carrier frequency Fc. The band pass filter has a frequency, centered frequency Fc. The band pass filter output and delayed version of it are applied to the correlator. Okay, output and delayed version both are, I have already told. The output of the correlator L is proportional to the cosine of the difference between the carrier angle. Okay, output is proportional to the cos phi. So here phi is the difference between the carrier phase angle of the received Dpsk signal and its delayed version. Okay, phi is the carrier phase angle, and difference between the carrier phase angle and the delayed version of the Dpsk signal, okay, in the same bit interval. So this was the about the Dpsk transmitter and receiver. And what is the merits of Dpsk? This scheme does not need any carrier at the receiver. This is the main aspect of this type of modulation. Due to this, the system complexity is reduced. Okay, so it is not an easy task to synchronize the both carrier signal at the transmitter and the receiver. So it is, the system complexity is reduced, and proportionally the cost is also reduced. The bandwidth requires less bandwidth as compared to Bpsk. The bandwidth is required is also less, as a carrier signal is also not used here. So demerits is, the scheme is modulation. This scheme of modulation provides higher value of probability of error. That is the problem. We have not calculated here, but as we have calculated for normal ASK, FSK and PSK, but in case of Dpsk also the probability of error is higher than Bpsk, and noise interference is more in case of Dpsk. In Dpsk, previous bit is used to detect the next bit. This is the principle of Dpsk, hence there is a possibility of error appearing in the pairs. So if previous bit is your error bit, then it will propagate to next bit. That is the main drawback of this modulation scheme. So we can see one example. Let's say a binary data stream, that is 1011 01100 is to be transmitted using Dpsk. determine the encoded and decoded output. So your binary data is Bk, that is 10110110. Now differentially encoded data Decay. We have seen in previous slide that if I will choose first Decay, I will choose 0. This is Decay, this is your Bk, this is your Decay minus 1. Okay, so I am choosing Decay's first bit as a 0. Okay, so 0 is transmitting, and this is 0, and your first bit is 1, 0 1, that is your 0. It will act as a 0 1. So 0 1 means x naught is output is your 0, because x naught output is 0 if input bits are different. Now this again 0, and it will 0 again if same, these are same bits, that's at 1, again 1 1, same bit 1, again 1 1, that's why same bit, and result will be 1, again different bit, result 0, different bit, result 0, different bits, result 0, same bit, result 1, different bit, result 0. So how we will calculate the phase? Phase is for 0 degree, for 0 phase is phi, for 1 phase is your 0, and for 0 again phase is pi, similarly so on and forth. So polarity of the integrator is there. For pi, this is the polarity is your plus, this is your 0 to the integrator polarity is nothing but your, so this is your plus polarity, and it would be pi to 0, this is your minus, so again 0 to 0, this is plus, 0 to 0 plus, 0 to pi, this is minus, pi to pi plus, again pi to pi plus, pi to 0, it is changing polarity to 0, minus, again 0 to pi, this is minus. Okay, so this is the your similarly sequence is the plus means 1, minus means 0, plus means 1, plus means 1, minus is 0. Okay, next similarly if I will choose bit as the first bit is 1, then I will get the sequence this. Okay, so in the next a binary data stream is to be transmitted using Dpsk. Choose D1 as 0 and determine the differentially encoded sequence Dk. Same, this is the your 0 1 0 0 1 1 0 1 0 0 1 1, same, the principle is same, and only data stream is different. We will get if different phase angle is there, then minus, if same angle is there, then phase is plus, and we will get the sequence this much. So and last one is this one is a binary data is this one, and transmitted using Dpsk shown in below figure. The channel introduces a phase reversal of 180 degree. Okay, so sketch the transmitted Dpsk waveform assuming an initial bit of 1. Okay, so here we are using assuming initial bit as a 1. So here minus 1 position means previous bit. Okay, so differential encoded bit is your 1 1. Okay, is 1 1 0, it will produce 0, same, it will like it will come 1 1 as 1, and the phase phase is nothing but your for 1 0, for 1 0 0, for 0 it is pi, and for 0 it is pi, nothing but the this is the for this is your 0 degree phase shift. Okay, then it here it is pi degree phase shift, again after that it will pi to 0 degree phase shift. So these are the some basic problems, and this is also one type of this is the receiver section. Okay, if I will transmit this signal, I will first I will delay 1 unit, so here 1 unit delay, after that I will this is the Dpsk waveform reverse in phase shift 180 degree phase shift. Okay, this is the waveform S1T delayed by TB, so this is a delayed signal. Output of the product modulator, I will multiply this and this will multiply negative negative will positive, positive positive will be positive, similarly it will come S1t multiply S1 t minus tb, and polarity will be, here it is plus minus, again plus plus minus plus, and due as according to plus I will put 1 and for minus I will put 0. These are the some basic problems regarding Dpsk signal, and these are the references we can see more about this section. So thank you very much.